Alright, so this video is about a few ideas. The main one is that bottom one there, succession. So we're going to talk about what succession is mostly. You already know what weather and climate are, but we'll be talking about those as well. Okay, so here's our idea here. Write this down. This is ecological succession. What ecological succession is, it's a series of ecological changes that occur in a community over time. Now, keep in mind that word community right here. Community means all of the living organisms in an area at a time. And what this is we're going to see the community kind of rebuilding itself. And that's what the second little statement down here says. These changes usually follow a period of disturbance. And we've all seen pictures of these. If there's a wildfire, you know that all the plants get burnt, bacteria are gone, all the animals ran out of there. But then over time, that all gets rebuilt again. Certain human activities can cause ecological succession to start happening again once they're over. If a house is abandoned and there's no one there to mow the grass or take care of the house, you guys know what'll happen. The yard will start becoming overgrown, the house will start falling apart, and then ecological succession is what's happening there. So there's lots of examples of this, where there's a disturbance, the entire community gets wiped out, and then nature starts to rebuild itself. Okay? Now down here I have a little questions because we've seen things like this. If a farmer doesn't use a field anymore, you all know that it's going to start becoming woods again. And basically the first creatures to move into that would be weeds. Okay, different wildflowers and grasses and things like that. And that's what's going to move into there to start getting that land set up again. So that's what we're talking about with ecological succession. All right, there's two types of ecological succession. There's primary succession, and here's the big difference between primary in the green and secondary in the blue color there. Primary happens where there's no previous soil. So it's going to take a lot longer because soil has to get made. Secondary succession, that's going to occur where there is soil. That's the huge difference. So I gave you some examples there of primary succession. That would happen after a volcanic eruption. You guys know that lava flow is going to harden and it turns into rock, and that there's no soil there, it's rock. So soil has to get made from that rock, and that takes a long time. It could take hundreds and hundreds and hundreds of years. Okay. Secondary succession is going to happen faster because with secondary succession there is soil there. So like our example before of a farmer who's no longer using a field, or a house that gets abandoned, well, that land is going to grow up and become weeds within a year. And then you'll see small trees in there, little mice will move in, snakes will move in, you'll have a whole food web being established. And then after maybe 10, 20 years, the trees are getting quite a bit taller, and you're to that mature stage really fast within decades. So primary succession occurs where there's no previous soil. It takes hundreds and hundreds of years. Secondary succession, there is soil available, and it just takes a matter of decades to reestablish that community to what it was. All right, with primary succession, there's a few vocab words you do need to know. The first species to grow is called the pioneer species. So think about Americans that were going west. Think like the covered wagons and all that. We call them pioneers because they were going to an area where they hadn't been before. And that's the same thing here. The first species to grow in the area is called the pioneer species. And these creatures called lichens are often the pioneer species. Here is a lichen. Okay, you've seen pictures of lichens before. So, here's a website here. You see a few different lichens. So these, you see them growing on tree bark. You see them growing on rocks and things like that. Lichens are really interesting. What they actually are is they're mutualism. So this flaky part that you see here, that's actually a fungus. And what the fungus can do is it can grow on the surface of the rock or here the tree. Now we're talking rock because we're talking about primary succession. And then the green color to these, it's really faint on this one, but over here you see it a little bit better. This green color is actually an algae that grows on top of the fungus. And it's mutualism. So remember, both have to benefit to be mutualism. So what the fungus does is it obtains moisture and it gives the growing surface. And what the algae does is it does photosynthesis and provides itself and the fungus with food. So the fungus is getting food from the algae, and the algae is getting a habitat from the fungus. So it's that mutualism, that win-win relationship. And those are the first creatures that can grow on rock in this thing called primary succession. Okay, so lichens are called the pioneer species with primary succession. Now what they do, like we just said, they can grow right on the surface of the rock, and that fungus can slowly break down that rock. And you all know that water can also break up rock too. Okay, as it gets down into the cracks of the rock and it freezes, it expands, it breaks the rock open a little bit. The lichen keeps making a small layer of soil, keeps reproducing. You'll get more and more lichens all over that rock. And then down here, this third one I have, the rock keeps breaking up. More plants grow, probably small plants, mosses, maybe some ferns, maybe some weeds can grow in that little bit of soil. And then as those plants start to die, they kind of make a layer of mulch as the decomposers break them up, which means more plants can grow in. Maybe some insects might find their way in there now. And what you're seeing is you're going from solid rock, and now you're really seeing the community that used to be there is starting to set itself back up again because that lava flow is no longer active. Now, let me show you a picture here. So here's a great picture. So here we start way to the left here, which is bare rock. That's what this gray layer is, okay? And then it's hard to see, but there's a little layer of green here. That's what they're calling those lichens. And then they'll break up the rock a little more. Some of those lichens may die and make a little bit more material for other things to grow on, and we get some mosses growing there. If you ever notice when you're in the woods, whenever there's a layer of moss, it's usually over top of a rock. And you can almost pull up the moss like a carpet. Well, that's because a lichen broke down that rock a little bit, and now the moss is able to grow on that. And then we see some weeds can grow in the cracks of the rocks or on that surface of where those lichens and moss used to be. And you can see we keep getting larger plant life, which you all realize means more and more animals are going to come in here to get food and to hunt the smaller animals. So we get a whole food web set up in there. And if you look, this layer of gray that ran throughout here, that layer of rock is still there. It got broken down a little bit, but we have broken up rock on top. We have decomposed organisms that make that nice phosphorus and nitrogen-rich layer of soil. And then larger and larger plants can grow on it. And then way over here, all the way to the right, you see it's called a climax community. And this took hundreds of years. A climax community is what was there before the disturbance happened, before the lava flow, before the glacier movement, before you even say like if there was pavement put down. Okay, that's almost like a rock. Even if a city was abandoned or a road was abandoned, we would see that nature would slowly take over again, and we would call that primary succession if it started off on a solid rock surface. All right, let me play this video for you because this gives you some good visuals of how this works.
Ecosystems are shaped by biotic and abiotic factors. But before biotic factors like plants, animals, and fungi can become established, we need abiotic factors like sunlight, rainfall, and nutrients. And today, I'm here with ecologist Joe Mascaro, and he studies how ecosystems change over time. And Joe's going to help us understand how we can start with solid rock, and through biotic and abiotic factors, they can change this rock to support life. So let's track the stages of primary succession by visiting lava flows of different ages.
So, Suze, this is the earliest stage of succession, where the rock's been colonized by lichen and some small sword ferns. These guys will colonize lava right away, almost the day after it cools. And once they do, they'll begin the soil formation process. So they'll grow, and they'll start to break apart the edges of these rocks, which are really friable and easy to break. And then the lichen will fix nitrogen from the atmosphere, and that will begin to build up soil on the surface of the rock.
Now let's move to the next stage of succession, one that's a bit older.
Well, Suze, this flow looks like the ecosystem has developed a bit more than the last flow. So you can see how there's so much more lichen than there was on the previous flow. It's almost like a carpet. And as the lichen grows, it's basically breaking up the surface of the rock and starting the soil formation process, which is really happening in earnest now compared to the previous flow.
The first plants that become established are early colonizers. Early colonizers have other characteristics. They're fast-growing, they need lots of light, and they're usually wind-dispersed.
That's right. And there's basically two types of early colonizers we might see on a flow like this. There's some that have a symbiotic relationship with fungi, and so they're able to fix atmospheric nitrogen directly and use it immediately. And then there are plants that are just able to tolerate really low levels of nitrogen, like ohia.
Okay, off to the next stage. So here we have an even older flow.
So we're actually going to see quite a bit more soil here than we saw in earlier flows. And we've really got a lot of moss. So we're really starting to see the ohias come together, and we're getting much closer to a closed forest. We're not quite there yet, but you can see how much taller they are and thicker.
Off to the next flow. So this is what scientists would call mature forest. It's over 300 years old. It might be hard to imagine, but this whole area was once barren lava rock. Let's go check it out.
So, we're definitely in a later successional forest now, which means we're dealing mostly with tree species that are not wind dispersed. They typically have big roots, maybe dispersed by animals. They're much slower growing, and of course, they tolerate shade. And as a result of all those features, they tend to need a lot more nutrients over time to grow.
All right. So as you guys could see there, that was primary succession. They started with solid rock, and then the community slowly changes that landscape over time until you saw that Climax Community. All right. Secondary succession is a lot less detail to it. Okay, with secondary succession, it's very similar to primary succession. The major difference is it takes less time and there's soil available. What that means is right here, plants can grow immediately, and then insects and other creatures are going to move in to eat those plants really fast. Down here it says it's the same pattern of growth as primary, except you really start with that plant life immediately. Okay, primary takes so long because you have to make soil. With secondary, the soil's already made. With secondary succession, the pioneer species would probably be weeds, wildflowers, grasses, things like that. Things that if you had a dead spot in your yard and didn't put grass there, what would move in there immediately? Dandelion, clover, weeds would move in there. That's because secondary succession is going to happen in that little tiny patch of grass that was bare soil. All right, our last idea. Guys, you know this. This is not unrelated to to ecological succession, but I just needed to make sure that we're on the same page with this stuff. Remember weather and climate. You watch the weather, you check the weather on your phone. You're trying to see the next few days of temperature and what's the precipitation going to be like. That's what weather is. Climate would be if you were going to move to California, you would want to know what the climate is like. You would want to know, does it snow there? Are there 4 seasons? Does it rain a lot? How hot does it get? That's climate. So weather is day-to-day conditions, which can change, but the climate is what happens year after year, and it's what you could expect from an area. Okay, so that's weather and climate. So jot those down if you needed to, and feel free to pause this video whenever you need to. And just keep in mind, these are already circled in there, but weather and climate are abiotic factors, and they obviously have an impact on succession. And we didn't get to that second statement yet, but just remember that weather and climate are abiotic factors, but they affect organisms, and that's why they're important. Okay, so that's our video about weather, climate, and succession. Succession took us the most time there, but make sure you get that all noted. That will be on your next test, and let me know if you have any questions.